Yeah, so hello again, everyone. I hope you are all excited for the very first talk, the very first session of Recon 2026, and it's based on a practical attack vector. So we are going to explore how applications are hacked. So this is the category of system hacking, system exploitation. So many people have heard about web exploitation, network attacks, web security. There are many fancy terms: cross-site scripting, SQL injection, access control, IDOR, SSRF, CORS, CSRF, and all those fancy attacks. And they are very easy to understand and easy to learn because we are all familiar with web. We all use web. We all have made websites, web applications. So we are very familiar of the functioning and the whole infrastructure. And also on the networking side, we do learn about networking, OSI model, TCP/IP, and what kind of attacks can happen in networks. So those are easy territories for us. And many people start from there only. But what about actual system exploitation? What about Windows? What about Mac? What about Linux? When someone gets access to your Windows, what else can he do? What more can he do? So we are very familiar about different access levels, different users on every machine. So have you heard about root in Linux? Have you heard about administrator in Windows? Those two are same, right? Like comparable, similar stuff. Have you heard about system in Windows? Or any term like anti-authority system in Windows? So admin is a high-level user, but system is even higher than that. And many people don't know the difference of system and admin. So we'll start with our talk, execution hijacking. And that seems like a very fancy term, right? But it's not very fancy. So this is the high level table of contents what we are going to explore today. First of all, the illusion. How Windows program actually works. How do you develop a program in Windows? So I'll start with the stuff you know, and then I'll go on to the stuff which is deeper. So how does a program is created? How an executable file is created and how a process is created from that. And then the trust issue. We are familiar about trust issues, right? How dependencies are double-edged sword. Dependencies can be helpful and they can be harmful as well. And the exploitation. So there will be a trust issue. How attackers exploit that? How conflicting is that? And then the ending, what to take from here? What do you learn? And where can you use it? So we'll get started. So I have given a high-level overview of who I am. And also, one of the major parts of my life is content creation. I do create content on YouTube. I'm a bit inconsistent now, but I'm used to. I've been doing this from the past 9 years, almost 10 years. So we know executable files, right? Dot. Whatever you can use. But those programming languages are human readable. They are meant to make you understand what you are doing. They are high level languages. So when you develop something in C, C++, machine doesn't understand it. Machine will not understand what you read, what you wrote. it needs to be converted to be understood by the CPU to execute instructions. And there is a difference between a program and a process. A program is something sitting on your disk. A process is something that's in your memory. That's a you develop something in C, in C++. So, like you develop something, the first line in C, what do? Hash include something, and then you start your program with the main function and you use some functions there. So that's your C program, a simple hello world program, you can imagine that. And if you want to create an executable, if you want to run that program, what do? You need to convert it into machine language, right? You need to convert with a compiler. So compiler is something that converts your high-level language to a low-level language that machines understand. And it's not enough. And what do you do in C program? You include certain functions, printf, scanf, malloc, all those things. But did you define those? Where are these definitions? How will the compiler understand what printf does, what malloc does? So it is stored somewhere in the libraries. So you need to include those libraries and those definitions from there. So when compiler compiles your program, it creates an object file. That object file has so many voids, so many missing pieces, because it doesn't know the definition of functions you have included that you haven't defined. So those definitions, where will it be? Where do you import those definitions? That's in your starting, right? That's in your starting. Hash include. That's your include. Let's take example of Python. What do? You import request, you import Django, you import whatever, OSIS, and then you use it. You didn't define it. Why will you define it? If somebody already defined it, why will you reinvent the wheel? Why will you? In this age of AI, many people will just ask ChatGPT to write a program, but it does the same thing. It includes many things, and you have to be intelligent enough to know that if those libraries actually exist in your system. And then there comes another program called linker. And linker does those things. You included something and it references where it is. You included stdio, you included strings.h. So that finds the address of strings.h, where it is located. So it puts the references in your program. That's it. Those definitions are not yet included in your program. Only the links are included. And then it's created. Then your executable is created. So now it's a compiled program. Now your exe is ready. This sits on your disk. It's not executed. When you execute it, it's in your memory. The program sits in your memory. And there is one more program called loader. Loader actually imports those definitions of include stdio, include something. So let's take an example of Windows now. In Windows, if you want to create a C program, there are many libraries you need to include, like Windows, for many other functionalities, for networking functionality, for file handling, for user handling. There are so many libraries. So Microsoft has given you the functionality to use the APIs that interact with the Microsoft Windows system. You want to integrate, you want to do file management, user management, disk management, networking. So it has created a lot of APIs for you. Those are called Win32 APIs. And those APIs are defined in DLL files. DLL files contain the definitions of API, and we don't define them again, we just use them. So when the program comes into memory, every program has an import table. It defines what DLLs it requires. That's the task of linker. And then it comes. So it will know what DLLs your program requires. And then it tries to import from there. So this is the whole process of starting from the C source right to the program in memory and how it is executed. Like I said, programs don't run alone. They depend on external components. Most commonly in Windows, it's DLL files and system libraries. A lot of different functionality, a lot of different stuff you can do that you don't define yourself. Like sharing resources and data. Most common functions are UI interaction. If you want to create a UI of your application, a GUI, then you need to use Win32 APIs, and there are many different DLLs for different functionality. So if I talk about some functions like if you want to implement networking, if you want to share or receive packets, upload packets somewhere, then you need to use WinSock API. WinSock is WS2_32.dll, and there are many other different UIs. So DLLs, what is the full form of DLL? I haven't written it here, but I've shown it. The full form of DLL is dynamic link library. The definition, the very definition of that URL tells you it's dynamic. What does it mean? It's in memory. It's loaded in memory. It's not included in your program. Dynamically linked library. Have you seen this error at any point in your life? Any error like this, any DLL error? The program can't start because some DLL is missing from your computer. While installing some games, it happens a lot. Games import a lot of DLL files because it has a lot of UI functionality, a lot of UI heavy processing. And many UI functionalities imported from Windows DLLs. Also networking, also files. So this kind of error is very common. And why this happens? Because your program is trying to import something your system doesn't have. Maybe you deleted it from that path. Or maybe your system is not installed properly. Maybe there is a malware in your system. A lot of reasons. But this is the exact error that the attacker can exploit. So if you go a bit deeper, how does your program load a DLL? If you talk about C#, then there is a function called load library. And then you write the DLL name. Load library is itself defined in some other DLL. It's defined in kernel32.dll. So when you are trying to load something, you use something and that usage is also loaded from somewhere else. So then your DLL is then loaded into the memory. And then in one DLL, there may be many functions, lot of functions. And many functions, those functions are exported and they let you know that we are ready to be used by your program. And one important thing is that a single DLL can be used by many different programs in the memory at the same time. It's called a shared library for a reason. It's shared. Once it comes into the memory, different programs running at the same time can use the same space and use the same function at the same time. So now talk about trust issues. So I have told you that DLLs are imported from different locations, right? But what are those locations? What is the path where your program looks to import the DLL for the function? So let's talk about the DLL search order. So there is a predefined order of loading DLLs. So DLLs are your part of Windows system. When you install Windows, DLLs are installed at that time, right? So where is Windows installed? Where are system files? Do we know? Where is it installed? In which drive it is installed? Do you know? C drive? C drive, right? So C drive has the folder called Windows. Inside a Windows folder, this is where Windows is installed. There are so many different directories inside Windows. So one of those directories is system32. And there is one more directory, system. This is where your DLLs are placed. So whenever you import something, it starts not from the system32, it starts from your directory where you started it. So just imagine of how you execute program. You execute program from a directory. It's stored in documents folder, downloads folder, and you execute it. If it requires something, where will it search first? If you require something, if you're writing something, your pen ink got exhausted, where will you search it first? You'll search it on your table first, right? And then you'll go on to your cupboard or any other place or any other stationery. So the nearest thing is searched first. The most local thing is searched first for saving time, saving efficiency. So the first thing it searches is the application directory, application installed somewhere, and it searches there first. If it doesn't find there, it will go to system 32 because that's where it will mostly find it. If it's not in system 32, it will find in system. But if it doesn't even find in system, it will go to the current working directory. So what's the difference between application directory and current working directory? Those both are different things. Open a command prompt, it will give you the working directory, initial working directory. And you can cd into any other directories. So it depends on from where you are executing this exe file in the CMD. If you are executing from the default directory, it will be C Windows System 32 by default. So that's your current working directory from where you are executing it. Application directory is where the application sits, where it is installed. So this order is very important. This order is very important. You need to pay attention here. And then come to the path variable. So path is an environment variable where a lot of paths are stored to search for something. If you don't define the exact full path, it will default to some paths to search. And there is a common pattern here. If you notice the order, the very first location application directory. Okay, think about it. Where your programs are installed in Windows. In which directory your programs are installed in Windows? C, program files. And there is one more x86, but program files only. And program files is only writable by the admin. So if you want to change something in application directory, you are not able to change if you are not an admin. And even system 32, it's only writable by the admin. System, again, current working directory, is it? It depends. Current working directory can be anything. It can be C users public. It can be writable by anyone. So we don't know. But the order is from the starting, only admin directories are searched. So it's safe, right? It's safe because not everyone in your system can be an admin. It's safe. So since this search order is safe, that's why it's the default search order. So this order which I told you, it's called safe DLL search. And there is one more which is not safe, which can be enabled in some programs, in legacy programs. So what happens in that? With the safe search order, we are first looking at the application directory, then system 32, then system, then current directory. But without safe search, the current directory comes before system 32. So current directory can be writable by even a low user. So if it doesn't find the DLL in the application directory, it will go on to your current directory. If you have the DLL in the current directory, it will load from there, not from system 32. So it creates a mishappening. And how can it be a trust issue? How can it be a trust issue? Let's see. So it's very obvious that if you want to load safely, if you want to load from exactly a particular location, give the whole path, absolute path of the DLL. Like I know there is the DLL, C program files app example.dll. This is absolute path. There is no ambiguity, no confusion. Just load it from there because it's writable by the admin only. Unsafe loading, what it does, I just given the file name. I don't know, just search for it. It's your task. Example.dll can be anywhere. So if I don't give the path, what will it do? What order will it follow? The order that I just told you, that search order, it will follow that. And by default, it will follow the safe search order. So multiple locations will be checked, and where it finds the very first occurring, it will pick up that file. So developers do this due to many reasons without specifying absolute path. It can be convenient because this is a very not a very well documented or regulated territory. In web, in network, we have a lot of visibility, a lot of attacks, so many things happening. But here in system exploitation, in DLL exploitation, it's much less explored. And that's why developers are not very aware and not very hygienic about exporting and importing dependencies. So mostly, many times they will include just the file name, not any path, because they know there is a search order and it will pick it up. If you have any extensions of your program, it will be loading dynamically, and it's not necessary that your DLL will be present in system 32. Your system can be corrupted, your system can be exploited before or having some missing DLL itself. So the trust issue here is we are following the search order, but we don't know where the DLL is missing and where it can be placed by an attacker. It is just trusting the order. The order is safe. Application directory, then system 32, system, current working directory. Order is safe. I'm just using the safe search order only. I'm not even going to unsafe. Just imagine the safe search order. The very first directory, application directory, that is assumed to be safe. Security is mostly broken based on assumptions, not on bugs. That's very first thing. So that very first directory is assumed to be safe. But is it safe all the time? Application directory, can it be safe all the time? So program loads a DLL without path, with no path, and DLL may be missing in some of those paths. In system 32, in application directory, in current working directory, in any of the paths it can be missing. And attacker wants to see where he can write in that path. Where he can write in that path. Application directory, current working directory, system 32. If he can write in any of those paths, and if before that path the DLL is missing, then he can force the program to load his own DLL, his own malicious program, and it can be run with the privileges of the program. So weaponization happens like this in real world. How this is exploited in real world? Because I'm telling from experience. I've been working in bug bounty. We receive a lot of reports today as well in this age of DLL hijacking. And in many programs, I cannot reveal the names, but still there are many unpatched issues of DLLs. So it's very common today. First of all, you might be wondering if somebody has to exploit DLL hijacking, he has to have write access to some folder of your machine. But how does it get it? If somebody is already in your machine, why will he have to do the hijacking? He's already having access to your machine. What's the difference? Difference is the access level. The low level user cannot do many things. He cannot see privileged folders, files, and many of those things are inside admin folders only. Many of your sensitive files, many of your personal files as well. It's divided based on users. So if he has access to a different user and you are a different user, your files will not be accessible by him. But admin has access to everything. Admin has access to all the users on the machine. So that's what he wants to do. He has a low user. Let's assume he gained access to your system via phishing, via your credentials. You leaked your Windows password somewhere, or there is a data breach, widespread data breach, and you're reusing those passwords in your Windows machine, and he got access to your machine as a low user, as your own user. And it can happen by any systematic bug as well. Somehow he has access to your system as a lower level user. And then his target is to elevate his privileges to system. System is the highest level of privilege in Windows machine. It's not a loginable account. It's a reserved account, a kernel level account. So now we use a tool called Procmon to identify the events created by programs. It can be any event where it is interacting with your Windows machine. It can be accessing registry. It can be loading a DLL, creating a file, reading a file, or deleting something. Anything that's happening with your Windows machine by the program, it's all captured in that Procmon. And Procmon is provided by Microsoft only, officially. So he uses that Procmon, and it identifies, it loads that application, it sees which DLL is missing. The path, the entry is recorded in Procmon, and he knows how to identify some DLL which is missing and where it is being searched, and can he write to that directory? If he can write to that directory, he can force the program to read his own DLL. And then he drops that DLL with the same name. The name should be the same. It's very obvious. And the code will be malicious. And the malicious code can be anything that he wants to persist in the system or do some malicious actions. And this can be weaponized to get system only if the program is running as system. If you want a program to be run as system, it needs to be created as a service. So when you create a service in Windows, it runs as system if you define it, because it should run for all the users. So this is the weaponization. So there are many types of DLL hijacking, not just about search order hijacking. Like I told you, search order hijacking is very common, and it has 3 subtypes. First of all, side-by-side and application directory hijack. It's also called side loading. So it's the very first directory where the search is happening. So if you are able to place that program in that very first directory, then it's hijacked. And then current working directory, that's lower in the order, that's the 4th, 5th place. But it's very rare to get to that place because system 32 will already have it mostly. So it's very difficult without unsafe search order. And unsafe search order are very less common today, to be honest. So what's happening is with the safe search order only. And like I told, plugin extensions can also do that. And DLL proxying. So proxying is an interesting case. So attacker places the DLL somewhere, the program loads its DLL, but it also tracks what the program is trying to do. So there is a legitimate DLL with that same name, and there is a malicious DLL with the same name. The attacker is in the middle. It can control what's happening, but it can also relay the exact commands to the saved DLL, to the actual DLL. So it will look like your program is doing the right thing. Your program is executing normally, because all the commands are going to the saved DLL, to the actual DLL as well. But your program is first connecting to the attacker, and then attacker is sending to the genuine one. So it's a relay. So it's a stealthy method to do DLL hijacking. And why it still exists? Like I told, I have seen many type of reports, such reports in my bug bounty career. Because it's not a bug. It's not a bug. It's just assumption. It's just trust issue. We are following safe search order only, but we don't know what is writable and what is not. And what if the program is not installed in program files? That can happen as well. It's installed in some C/something, C public/something. It can be writable. It depends on many other misconfigurations, context to context. So there is no bug actually, it's the design behavior. And it's very hard to fix because we don't know, because it happens after the system is installed. You have accidentally given write access to some folder, and then it tries to go from there. So it's hard to fix. Like, what will you fix here? If you fix something, you break something else. It's not a safe fix. And the risk is very underestimated. Yeah, if the program is running as a low user, then you gain access to low user only. So there is actually no real benefit of DLL hijacking. But yeah, if it's running from admin privileges, you will gain admin in that system. That's all for the theory. That's all. We can move on to the practicals. And this is about DLL hijacking. This is about how to break trust issues. We can see now how it's broken. If you want to do it yourself, you can do it yourself as well. I have a file on Drive. We can share that. after listening ports, the list of listening ports, there is one more log entry attempting to load netutils.dll. And then it says netutils.dll loaded successfully. And then there are some other functions working here. So it's trying to load a DLL and it's loading successfully. Okay, this is how we know how this program works. I'll close it. And it's still running in the background, it's still running. It's not cancelled. It's not showing any entry on the command prompt, but it's generating a log file. It's like a service. So you can register this as a service as well. I'll close this one for now. Now I'll open a software called Procmon. It's here only in the process monitor folder in the lab files. There are 3 executables, Procmon and 64 and then A64. I'm running Windows on a Mac system. I'm running it in UTM VM. So I'll open the A version. I'll open this program. Okay. So this is the window of this program. From the top menu, you go to the filter and select the filter option. So by default, there is no filter selected. So it will just keep generating entries. So what kind of entries it's generating? If I can just full screen this one. So if you can see, there are many processes in the process name tab, lsas.exe, explorer.exe, cfmon.exe, and then there is process ID, operation, path, and result. So this process is trying to do some operation on some file, and then it's showing the result of that operation. So there are a lot of processes running in your system, and it's logging entries for every program. So you can see what each program is trying to do with your Windows system. Most common entries are registry open, registry write, create file, close file. Registry queries, a lot of registry queries. But we don't need this noise, right? We don't need for each process. We need for one particular process that we need to find. So right now it's already generated 4 lakhs, more than 4.5 lakhs result, but we need to filter out the result for just our process. So we'll go on to the filter tab again, click the filter option, and we need to find the entries for our program. So we'll click on the display entry and try to filter by the process name. There is an entry, process name. Do we know the process name? Okay, I'll try to execute it once more. netmon.exe. I'll try to open one more tab. I'll try to find the process name. So there is a command task list, and I'll just find it with this netmon. So there is one process, netmon.exe. So this is our process name. If you don't know, you can just search with the list of the task list result. And then we know. So now I'll put here netmon.exe. I'll just put the process name as a filter. So is this filter name enough? I'll just try to apply. Okay, it's significant now. A lot of results are removed. It's only showing me 693 results. But there are still so many. So many results. We don't know all of this. We want to find out which DLL is it require. I mean, which DLL it is trying to load and from where it is trying to load. So I'll try to filter one more. I'll try to filter with the name DLL. So it will be in the path entry. So path contains, I'll choose contains here, not is, but contains dot DLL. And I also know the DLL name, but I'll just do it dot DLL for now. And then I'll add one more filter here, dot DLL, apply. Okay, so now it's again filtered. It's showing 175 results, but it's still so much. We want to filter even further. So what do we need to find? We don't need to see the success results. We know that success is not our criteria. we need to find those results where the DLL is not found so that we can place it there, right? So we don't need the result as success, we only need the result as name not found. Name not found is the result type where the file is not found by the program, the process. So then it moves on. So we'll filter one more. We'll select result is name not found and add it. And I'll apply once again. So now we have significantly reduced the result size. I'll increase the font if it's helpful. Yep. So as you can see, if you can see, the process name is netmon, the single PID, operation is create file, path. In path, you can see there are so many entries and it's still creating entries, one more. And with the result name, the result is name not found. Do we need this script? So try to see where it is trying to load it. See netmon net utils.dll. So if you know it's the exact same directory where the program is installed. Do you relate now? What I told you, the search order, the very first entry was application directory in the search order. I mean, for guys you're trying to replicate, are you able to follow or are you stuck at any step? You're able to follow? I mean, yeah, you can ask doubts after that. But so it's trying to find the directory inside the application directory, netutils.dll. So it's still trying to find it out. But if you recall, in the log file, it says the netutils.dll was found. How is it possible? How is it possible? Like it was trying to find the DLL, it's not found here, but it still said it's found in the log. Why it was found? So this is the code of this DLL. This malicious DLL that I have created. So there is a main function DLL main. It executes as soon as the DLL is loaded into the program. And then there is one init function. So init defines what something is to execute first before executing any other function. So I have inside init, I have called a system routine cmd.exe. So I'm calling a program command cmd.exe. So this is my malicious DLL. And inside this system.exe, I can write anything. If it executes under admin permissions, I can write any command that I would write in a cmd.exe. So for now, I'm just opening cmd.exe in this DLL. So I also have a compiled version of this in the same lab files. So netutils.dll, this is the malicious DLL. So you can write this in the netmon directory. So I'll use another command prompt. What I'll do is I'll copy this DLL, netutils. It should be the same name, exactly the same name. And I'll copy it to C/netmon. One file is copied, but yeah, you can see this admin prompt. I'm admin currently, so it's very obvious that I can write to it. I should not be an admin. I should not be an admin. I'll just remove this once. Delete. Delete. So what I'll do is I'll open a command prompt normally as a normal user. So I'll do run as user low privileges. I have a low privilege user, and what I'll run is I'll run cmd.exe. So now I have logged in as a normal user. So here I'll go to the cdc users. I also place this DLL in a public directory, public/temp, so that any user can access this. So netutils.dll, I'll copy this into C/netmon. It says one file copied. So that means as a normal user as well, I'm able to copy to that directory. So that verifies our permission level. I was a user and I am able to write to that directory. So now let's check our Procmon. I'll need to remove all these entries first. I'll exit now. Let's see if this program is still running. Yes, it's still running. So netmon.exe is running. So let's try Procmon once again. If it's generating the same error. So the filters are same. The filters are same, but it's not generating any name not found now. So it's trying to find first in that same directory and it got that. So it does not have any name not found issues now. So I'll go to netmon and I've placed netutils.dll here. Netmon.log will be there. Netmon is the program, but there is one more file, pwned.txt. Let's see what's in this file. This is the user which is running the program, from which user this program is running. I ran as my user, tech hacker, but I placed it as what user I placed it as. Do you remember the user? What user I placed it as? I mean the DLL. I injected the DLL as low priv user. Low priv was a different user. If I do here, who am I? Who am I? If you can see. Who am I? I am low priv. So this was low priv user and I copied it as that user, but I am able to execute program as stack hacker. So I placed a DLL with a malicious code that's just trying to print the who am I in a file. And this is the attack hacker user. So I'm able to not escalate privileges, but able to run something as a different user. So if this was your user, if this was your user account, I'm able to run something as your user account. And you will have access to your personal files, right? And the more close attack vector in real world would be creating a service out of this program. So I've written this command because it's not very easy to remember. So creating a scheduled task as a system. So this is one command. What I'll do is, as admin, I'll run cmd as admin once again. So I'll create a netmon task out of this netmon.exe and run as system. So first of all, I need to remove that process first, which is running already. -str netmon. See command for process kill, task kill. Okay, that process is dead now. I've created a scheduled task. Now I'll run that scheduled task. So this happens a lot in real world when system admins create a service out of this program, because it is like a service only. It is trying to log entries, not log network entries into a file, and report malicious entries as well. So I'm running this scheduled task now and it says success. So now I'll see this file again. Now there is one more entry in this file. It will keep creating entries in this file now. And this time the entry name will be different. This time it says NT-authority/system. Previously it was tech hacker. So system is the highest privilege in Windows, even more than admin. So this is not a standard account. This is a service account. I mean system account reserved for system. So now you are the biggest user in this system. You are the root of this system, you can say. So you can do anything and everything you want in this system. Now you have completely hijacked this system. So what I demonstrated was, I installed a program and I saw the functionality first, what it's doing. That's very important because people jump right into hacking and follow cheat sheets. That's just very low level script kiddie stuff. Just understand first what application is and what it's trying to do, what's the behavior. I run this netmon.exe. I try to understand what it's doing and then try to find what DLLs it is trying to load from Procmon and which DLLs are not found. And I found that it's trying to load a DLL from its own application directory. And I had write access to it. And then I placed into that directory. So I hijacked the DLL search order, right? What's the order? The very first path is hijacked itself. So it doesn't matter if it's safe, is it unsafe. It doesn't matter. The order doesn't matter now. So that's how safe search orders are also hijacked. It doesn't matter to be unsafe. So this is what real world means. And this is how hacking is done. This is actual hacking, if you want to know. If you haven't done any hacking in real world, this is how it's done. So this is all technical. This is not something fancy or any UI that you will get with one button called hack. And you will get the NASA control panel. It's not possible. So this is how hacking is done. This is very subtle, very simple, but there are many complications in real world, I must say. But Procmon was provided by Microsoft. This netmon is a program that I created, but it doesn't trigger any antivirus warning, so it's very, very safe. It doesn't include anything malicious. So everything I have done here, it's all by design. There is no bug. It's just assumption. Application search order is safe. Procmon is safe. Netmon is safe. What else? Only that DLL is malicious. And even that is not malicious. I just did cmd.exe. Is it malicious? Or I just did who am I and write to a file. This is not malicious. So if I want to weaponize it, I want a reverse connection to my machine. That might be malicious, but I know how to obfuscate that. I know how to filter that. But till now, there is nothing out of the line. There is nothing unusual. So there is no way someone can know that this happened in their machine. So this is how DLL hijacking works. And this was the demo. I hope like people, if you're trying to replicate, you're able to do that. But if not, we can have the demo commands as well in the file. So you can download from that as well. So I hope you like the demo. I hope you like how DLL search order, I mean, basically execution hijacking works on the high level and how trust boundaries are exploited. And maybe this sets up the momentum for this event. And so many other stuff, so many CTFs you will do, so many king of the hill challenges you will do. CTFs do have this type of challenges as well. And so many exciting things, web, crypto, binary. I've done this myself, so I know how fascinating it is. So I hope it will be exciting for you. But right now, this is all I've got. This is all I have to say. If you have any questions, I'm happy to hear. But thank you all for listening. Thank you so much for listening. Thank you so much for being here. Thank you so much. And because it's going to be a great ride for your career. Well, all the best.
Thank you so much, Ansh. It's a very, very fruitful session. Thank you for the demo and the wonderful presentation that you would put up for us. Now, I'd like Ansh to please join us on stage as we would like to felicitate him. I'd like CV sir to please join us on stage as well. And also Ganesh sir.
Very emulating session, sir. Good present.
Thank you so much.
Can you have a quick round of applause? Will be eating in the sack. Yes.
And as per the participants,